Welcome, everyone, to a journey into one of the most exciting frontiers humanity has ever faced. Today, we're going to explore what happens when the principles that govern the tiniest building blocks of the universe start reshaping the way we live, work, think, and dream. This isn't about a single invention or a new app, it's about an entirely new foundation for progress. One rooted in the strange and beautiful rules of quantum mechanics. And the best part, we're already standing at the edge of this transformation. Picture this. For hundreds of years, we've built our world on ideas that make intuitive sense. Objects have definite positions. Causes lead directly to effects. Information travels at predictable speeds. These rules have given us bridges, airplanes, smartphones, and space stations. They've worked brilliantly. But now, scientists, engineers, and innovators are unlocking a deeper layer of reality where those familiar rules no longer hold absolute sway. Particles can exist in multiple places at once. Distant objects can influence each other instantly. Reality itself seems to respond to being observed. These aren't just curiosities in a lab, they're becoming tools we can use. At the heart of this change is quantum computing. Unlike ordinary computers that process information one step at a time, using bits that are either 0 or 1, quantum computers use qubits. A qubit can represent 0 and 1 at the same time, a property called superposition. When you combine many qubits, the number of possible states grows exponentially. A few hundred qubits working together can explore more possibilities simultaneously than there are atoms in the observable universe. That kind of power opens doors we barely knew existed. For example, discovering new medicines today can take years. Researchers have to test thousands of chemical compounds to find one that safely treats a disease. A quantum computer could simulate the behavior of molecules at the atomic level far more accurately than any classical supercomputer. It could screen millions of potential drugs in days instead of decades, bringing treatments for cancer, Alzheimer's, or rare genetic conditions to patients much faster. Imagine a world where a new pandemic threat is met, not with years of frantic research, but with targeted solutions designed almost as soon as the virus is sequenced. But medicine is just the beginning. Climate change demands urgent answers. Quantum systems excel at optimization, finding the best solution among countless options. They could redesign global supply chains to slash carbon emissions, determine the most efficient layouts for wind and solar farms, or discover new materials that capture carbon dioxide straight from the air more effectively than anything we have today. Renewable energy storage is another huge challenge. Batteries need to hold more power, charge faster, and last longer. Quantum simulations could guide chemists toward breakthrough electrode materials or entirely new battery chemistries that make electric vehicles cheaper and clean energy grids more reliable. Now let's bring this closer to everyday life. Secure communication is becoming vital in a connected world. Quantum cryptography uses the laws of physics themselves to protect data. If someone tries to intercept a quantum encrypted message, the very act of spying disturbs the signal and reveals the intrusion. Banks, governments, hospitals, and even ordinary people could exchange information with confidence that no hacker now or in the future could ever break in unnoticed. As quantum networks expand, we might one day have a quantum internet where privacy is guaranteed not by complex math, but by the unbreakable rules of nature. Of course, change this big doesn't happen in isolation. It ripples through every part of society. Education will evolve. Children growing up in the coming decades will learn not just arithmetic and algebra, but probabilistic thinking, how to reason comfortably with uncertainty, how to weigh multiple outcomes at once. Schools might teach quantum concepts through hands-on experiments with simple photon kits or cloud-based quantum simulators that anyone can access from a tablet. Critical thinking will include understanding when classical approximations are good enough and when quantum precision matters. Workplaces will transform too. Architects could use quantum algorithms to design buildings that maximize natural light while minimizing energy use, testing thousands of variations in minutes. Farmers might rely on quantum-enhanced weather models that predict microclimate shifts days further ahead, helping them decide exactly when to plant or harvest. Logistics companies could route fleets with such efficiency that traffic congestion and fuel waste drop dramatically. Creative fields will feel the impact as well. Musicians experimenting with quantum-generated soundscapes, filmmakers crafting stories with branching realities, writers exploring narratives where every choice truly matters. One of the most intriguing possibilities lies in sensing and measurement. Quantum sensors are extraordinarily sensitive. They can detect tiny changes in gravity, magnetic fields, or time itself. This could revolutionize navigation. Imagine vehicles or drones that guide themselves perfectly even deep underground or in stormy seas where GPS signals fail. Medical diagnostics could become far more precise, spotting the earliest signs of disease through subtle shifts in biological fields. Astronomers might build quantum telescopes that see farther and clearer, revealing planets around distant stars in unprecedented detail and bringing us closer to answering whether we're alone in the universe. Yet with all these opportunities come important responsibilities. Power this great must be shared wisely. Not every country or company starts from the same place. Some have more resources to invest in quantum research than others. If we're not careful, the benefits could concentrate in a few hands, widening gaps instead of closing them. That's why international cooperation matters so much right now. Scientists from around the world are already collaborating, sharing discoveries, and working to make quantum tools accessible through cloud platforms. Governments are launching education programs and workforce training initiatives to prepare people from all backgrounds for the jobs this new era will create. We also need thoughtful guidelines. Quantum computing could one day break many of today's encryption methods, so we have to transition to quantum-safe standards before that happens. Researchers are already developing those new protections and testing them rigorously. Questions about data privacy, algorithmic fairness, and environmental impact. Quantum systems often require extreme cooling, so energy efficiency is a priority. Deserve open discussion involving technologists, policymakers, philosophers, and the public. Let's take a moment to imagine a typical day a couple of decades from now. You wake up and your home assistant, powered by quantum-optimized routines, has already adjusted the temperature and lighting based on weather forecasts, your calendar, and even how well you slept. On your way to work, your electric vehicle navigates the smoothest route, coordinating in real time with thousands of other cars to avoid congestion. At the office, you join a global team brainstorming solutions to a complex engineering challenge. A quantum cloud service runs millions of simulations overnight, presenting the most promising options for you to refine with human insight and creativity. During lunch, you check in on an elderly relative. Wearable quantum sensors have been monitoring their health gently and continuously, alerting doctors to subtle changes long before symptoms appear, allowing early intervention that keeps them independent longer. In the afternoon, you attend a virtual concert where the music adapts in real time to audience reactions, creating a unique performance every single night. When you get home, you spend time with your kids, helping them with a school project designing a simple quantum circuit on an educational platform that lets them see superposition and entanglement in action. Through colorful, interactive visualizations, this future isn't guaranteed, but every major milestone we're hitting today makes it more likely. Fault-tolerant quantum processors are getting closer. Error correction techniques are improving rapidly. More qubits are being linked coherently for longer times. Companies large and small are building practical applications. Universities are graduating new generations of quantum savvy engineers, physicists, and computer scientists. Open-source quantum software frameworks are letting developers everywhere experiment and innovate. What's especially encouraging is how this field attracts curious minds from every discipline. Mathematicians refine algorithms, chemists model reactions, biologists explore quantum effects in living systems. Some researchers believe photosynthesis and bird migration already exploit quantum phenomena. Artists and designers bring fresh perspectives to user interfaces and visualization tools. Philosophers help us grapple with what it means to live in a reality shaped by probability and interconnection. At its core, this transformation invites us to adopt a more flexible, open-minded outlook. Classical thinking often seeks a single right answer. Quantum thinking embraces many valid possibilities coexisting until circumstances select one. That mindset can make us better problem solvers, more resilient in uncertainty, and more appreciative of diverse viewpoints. It encourages collaboration over competition, curiosity over fear of the unknown. We're not passive spectators in this story. Every choice we make today, learning a new skill, supporting responsible research, advocating for equitable access, or simply staying informed helps shape the direction this tech. We're not passive spectators in this story. Every choice we make, today learning a new skill, supporting responsible research, advocating for equitable access, or simply staying informed helps shape the direction this technology takes. The quantum era isn't something happening to us, it's something we're building together. So as we move forward, let's approach it with wonder, caution, and optimism. Let's invest in education so everyone can participate. Let's prioritize applications that heal, connect, and sustain rather than divide or harm. Let's keep asking hard questions and demanding transparent answers. The principles that govern the quantum world have been around since the beginning of the universe. Now we're finally learning to speak their language, and what we say with it is up to us. Thank you for joining me on this exploration. If any part of this resonates with you, you're excited about the possibilities or curious to learn more, take a small step today. Read an article, watch a beginner-friendly explanation, or just share this conversation with someone else. The future we're stepping into is bright, full of potential, and wide open for all of us to help create.